We're going to be talking about what keeps hybrid multi-cloud networking using Equinix Network Edge and Equinix Fabric working in harmony, specifically focusing on device link groups and bring your own connection ports.
This is the under the hood part of the design. It's how your redundant routers and firewalls actually stay in sync, how they exchange control state, how you extend those same resilient connections to your private environments. Without these elements, you just have these isolated virtual boxes. DLG and BYOC are what make this a fully connected enterprise-grade architecture.
Let's start with device link groups. We have these 2 routers, 2 firewalls, 2 planes. But how do those redundant devices actually communicate and behave like one system?
So a device link group, or DLGs, they're private layer 2 networks that allow those paired devices to communicate directly with each other. Each redundant pair, like your routers or firewalls, should have its own DLG. That links all the high availability related traffic, heartbeat signals, state synchronization, return path information, so the secondary device always knows what the active one is doing.
So it's like their private language, like a channel that keeps them constantly talking and aware of each other. So then if something happens to the active firewall, the secondary already has everything it needs to take over.
Right. If you think about the network gear in a rack, you have the network cables that connect redundant devices together. Or you need layer 2 paths between devices for service chaining. And then the flow of data can follow these dedicated paths versus one connection between devices that squeezes all of that data through. DLGs are the virtual version of those layer 2 network needs. DLGs operate over a secure, low latency network within Network Edge, and they can even extend those links across metros using Equinix Fabric. So if you've got one device in Dallas and another in Ashburn, then you can still stay perfectly synchronized in real time.
Especially for these global organizations where workloads are distributed, it's a big advantage for business continuity design, being able to fail over between metros while keeping that control state intact.
And for most teams, it's a huge simplification. Traditionally, you'd manually cable devices together or configure separate VLANs for this layer 2 traffic. With DLGs, it's all handled through the portal. You choose which devices to link, assign VLANs, and you're done. Behind the scenes, the platform keeps those links resilient, isolated, and optimized for HA traffic.
That's actually what makes high availability actually work in practice and not just on paper. What's actually happening during a failover? What role does the DLG really play?
So let's take the firewall pair as an example. You've got active-active firewalls here handling live traffic on separate planes, listening in. Every few milliseconds, the primary firewall sends heartbeat messages over the DLG and syncs session tables, NAT mappings, and configuration state. If those heartbeat messages stop, maybe the primary device fails. The secondary automatically takes over within seconds. Because the session data is synchronized, the traffic continues to flow without interruption. So from an end user standpoint, they don't see the disruption and it's seamless.
That's really impressive. And it really drives home how important that constant synchronization is. Because without it, you'd have to rebuild sessions or even reestablish connections manually, which could mean minutes of downtime. And we all know what even a few minutes of downtime can really mean for a business.
Exactly. And the best part is that this resiliency isn't just virtual. Remember, those redundant devices sit on 2 separate physical planes, plane A, plane B, each with its own compute, power, and network path. So even if one entire plane experiences an issue, the other continues to run normally.
So you're getting that protection at multiple levels. The platform level with physical diversity and the device level with the synchronized state through the DLGs.
Yep, and that's what gives you enterprise-grade high availability. You're not just duplicating infrastructure, you're designing for true operational continuity. It's resilience by design, not by reaction.
Now, let's zoom out a bit. How do we extend that same reliability beyond Equinix, like out to a customer's private environment or, let's say, an on-prem site?
So that's where bring your own connection, or BYOC, comes in. In BYOC ports, they let customers extend their network edge deployments to non-Equinix locations. This can be private data centers, private clouds, or remote offices through a network service provider circuit. It's what bridges your external environment into the Equinix ecosystem.
So instead of being limited to what's inside Equinix footprint, customers can still bring in their own carriers and private lines, but with all the same redundancy principles we've been talking about.
Exactly. So I'll take a step back and explain BYOC a little bit. So BYOC connects a physical circuit from an NSP of their choice to your network edge device. So your NSP provides a letter of authorization, or LOA, that allows Equinix to patch their circuit into your BYOC port. In most cases, this circuit is a simple layer 2 connection. It could be VLAN tagged, untagged, and from there it behaves like any other link in your network. The BYOC port is actually a specialized Equinix fabric port that Equinix manages for you. So what we do is we create the virtual circuit then from the BYOC port to the network edge device. Now that is a single connection, but for our customer's design here, the BYOC goes into a pair of clustered firewalls. This is a special resiliency that the DLG built into the active-active devices can manage, and it allows either of the firewalls to communicate back over the BYOC circuit.
So that means the resiliency of the fabric network is baked into such things as the clustered firewall pair, which means you're not adding complexity. You're actually extending a foundation that's already engineered for that uptime.
True. And in our reference design, one NSP circuit is mapped, which can be seen as a single point of failure itself. For full redundancy, though, we recommend going one step further, deploy 2 diverse NSP circuits over separate BYOC ports, ideally from different providers. That gives you true path diversity end to end.
Okay, so you're taking that same high availability logic we just walked through, diversity, redundancy, isolation, and then now applying it to your external connectivity.
Exactly. It's the same pattern, just extended outward. Whether your workloads live in private cloud, a data center, or across multiple metros, BYOC lets you connect them all through consistent and resilient architecture.
That's some great context. They can keep their existing providers and extend private connectivity wherever they really need it and still get that reliability from the Equinix platform.
Right. It's about giving customers control and flexibility without adding more hardware or long provisioning cycles. Everything remains software defined, but built on an inherently redundant infrastructure.
For the teams looking to implement this kind of design, right? What are the best practices that you would recommend?
So I'll break it down into 4 key things. 1, design for diversity from day one. Don't wait until later to think about redundancy. Use separate planes, separate providers, and physically diverse paths wherever possible. 2, test your HA setup regularly. Failovers shouldn't just look good on paper. They should just be practiced, documented, and monitored so your team knows exactly what to expect. 3, automate wherever you can. Use APIs or Terraform to deploy consistently across the metros. Automation reduces human error and makes recovery faster. 4, monitor proactively. Like I mentioned observability earlier, keep an eye on latency, uptime, and HA events. The sooner you see drift, the faster you can correct it before it becomes an outage. Now follow those steps and you're on track for what we call 5 nines reliability.
I want to just bring this full circle. We've looked under the hood of how these device link groups keep redundant devices synchronized and how you can also bring your own connection ports to extend that reliability to these private environments.
DLGs, like you said, keep your redundant devices synchronized and fail-safe. And BYOC extends that same level of reliability to your private environments. Together, they give you a consistent foundation you can design on anywhere in the world.